There's a new passing score metric that was introduced in 2022. This article was published January 13th, 2022, and I'm going to talk about it, but if you want to skip ahead, I'll give a general overview, but this is going to be pretty much reading off of the article that was written. So this article says, competent quarterback play is a prerequisite for success in the NFL. The last 35 Super Bowl teams, 32 have featured at least one current Pro Football Hall of Fame quarterback or a quarterback who seems likely to eventually be inducted. We're operating with the belief that Tom Brady, Aaron Rodgers, Ben Roethlisberger, Drew Brees, and Patrick Mahomes are Canton-bound. Nevertheless, football remains the ultimate team sport, and attributing a team's overall success solely to who aligns under center is an exercise rife with problematic assumptions. Yet isolating a quarterback's play from his supporting cast and his play caller remains elusive, statistically speaking. Since the inception of the Next Gen Stats project, our focus has been to drive insightful analysis from cutting-edge metrics derived from on-field tracking technology. We started with statistics like how far the ball traveled in the air, example air distance, the distance between a receiver and the nearest defender, example separation, and even how fast the passer was traveling when he let go of the pass, example quarterback speed. As our toolbox of statistics grew, so too did the complexity of our metrics. In 2018, we debuted completion probability, a predictive model that can estimate the chances of completed pass using metrics like air distance, separation, and quarterback speed as features in the model. That same year, our team developed a different model to determine how many yards a receiver should be expected to gain after he catches the ball, expected yards after catch. These models help contextualize outstanding performances, though in isolation the statistical picture is rarely complete. Enter the Next Gen Passing Score powered by AWS. We teamed up with AWS ProServe Data Science Group to develop a more comprehensive metric for evaluating passing performance. Built off 7 different AWS-powered machine learning models, the NGS Passing Score seeks to assess a quarterback's execution on every pass attempt and transform that evaluation into a digestible score with a range between 50 and 99. The score can be aggregated on a sample of pass attempts while still maintaining validity in rank order. More on this later. Before we dive into the passing score formula, it is important to remember the why. A brief history of advanced passing statistics. Reducing pass performance to a single number is not a new concept. Almost exactly a half-century ago, then NFL Commissioner Pete Rozelle asked the league committee to create a metric that could use to crown the best passer in the league. Thus, passer rating was born. To this day, passer rating still reigns supreme as the most widely used metric to represent passing performance. The problem? Well, there are just too many to list. Chief among the criticisms of the metric, the formula hasn't changed over the last 50 years, while the league's passing environment has continued to evolve. Over the last few decades, there have been several worthy attempts to improve on the validity of passer rating. Pro Football Focus has an army of charters famously grade every play, which feeds into the aggregate grades of their own. ESPN's Stats and Info Group created QBR using the context of expected points. Aaron Schatz of Football Outsiders developed defense adjusted value over average, DVOA for short, which adjusts for the strength of the opponent in the play aggregation formula. All these statistical endeavors share a common goal: to isolate the contributions of a quarterback from the team's collective passing production and efficiency. No matter the difficulty of the throw, traditional box scores like yards and touchdowns will treat a 72-yard touchdown pass the same whether it was thrown 40 yards in the air and hits the receiver in stride, or if it was thrown to a wide open receiver 6 yards downfield who outruns the entire defense. The NGS passing score, like other metric for it, seeks to improve on the limitations of the traditional box score, a model to predict the value of the pass before the throw. We mentioned that the Next Gen Stats passing score is derived from a combination of 7 different machine learning models. They are listed in order of development: 1. Completion probability, 2. Expected yards after catch, 3. Expected points, 4. Win probability, and our newest models: 5. Interception probability or pass outcome probability, 6. Predicted yards, and 7. Predicted expected points added. A majority of these were already a part of the NGS toolbox. However, there was still a missing piece. A quarterback makes his decision to throw a pass not knowing the precise location of where his receivers and opposing coverage defenders will be when the pass arrives. So we set out to replicate the quarterback's decision process and predict the value of a pass attempt before the ball is thrown. By estimating the expected value of a pass attempt, we can more effectively evaluate a quarterback efficiency relative to the league average baseline. And in future iterations of the score, quarterback decision making, the output of our new predicted yards model serves as the basis for our play expectation metric. That is, since we can measure how well an average quarterback would perform in that situation by leveraging our completion probability model, we can control for the level of difficulty quality of their passes. That's not all. By going deeper into the outputs of our collective NGS predictive models, we find valuable data points that will serve as the components of our new passing score. How the NGS passing score works. Instead of simply awarding all passing yards, touchdowns, and interceptions to the quarterback, the NGS passing score equation leverages the outputs of our models to form the components that best evaluate passing performance relative to the league average expectation, isolate the factors that the quarterback can control, represent the most indicative features of winning football games, encompass passing performance in a single composite score ranging from 50 to 99, generate valid scores at any sample size of pass attempts. Armed with a collection of powerful AI-driven tools, it is only fitting we put pieces together to form the 7 measurable components that make up our new passing score, listed in order of weight in the formula. Expected points added over expected, EPAOE, accounts for 46% of the passing score. EPAOE measures production relative to an expected value using our new expected yards model and is calculated as the difference between the actual value of a pass and the predicted value of the pass before the ball is thrown, when accounting for the probability of each pass outcome, example completion, or interception. 2. Expected points added. EPA accounts for 8% of the passing score. Instead of quantifying the success of the play in terms of yards gained, EPA represents success in terms of points relative to the current play. 3. Completion percentage over expected. CPOE accounts for 11% of the passing score. CPOE is a derivative of completion probability, which measures the success of a passing relative to the difficulty of the throw. The CPOE feature is used in the score does adjust for dropped passes. Interception probability. Interception probability accounts for 11% of the passing score. Interception probability measures the likelihood that a pass will be intercepted if thrown. 5. Error expected points added. Error EPA accounts for 7% of the passing score. Error EPA is equal to the value of the completion plus the yards a receiver would be expected to gain after the catch. Error EPA is a proxy for the optimal reward of a pass within the control of the quarterback. Expected error EPA. Error EPA accounts for 7% of the passing score. Expected error EPA is equal to the value of completion plus expected yards at the catch relative to the likelihood of completion. Example, completion probability. 7. Win probability. WP is not a feature in the model, but it is used as an aggregation play weight. On any given play, the offense's pre-snap win probability for is used as a weight in the passing score formula, where closer to 50% win probability equals 1 and closer to 10% or 90% equals 0.6. Each component is converted into a standardized Z-score based on the population of all pass attempts from 2018 through 2021 seasons. N equals 70,439. To reduce the impact any one component has on a dominating score, each individual Z-score was selectively clipped at 3 or 4 standard deviations below and above the mean. A linear combination of components make up an individual play score that ranges from 50 to 100. Now on to the aggregation step. Take the average of individual play scores weighted by the offense's pre-play win probability using a parabolic shape centered at 0.5. In other words, plays in close games have a greater weight in the formula that plays closer to the extremes. Plays with less than 10% win probability or greater than 90% win probability are roughly 60% less in the aggregation formula than a play in the game at 50-50 odds. But that's not all. To account for a small sample bias, the passing score aggregation formula uses the James-Stein estimator to shrink predictions closer to the population average. This Bayesian approach became a popular technique in recent years to solve for small sample issues when predicting batting average in baseball. Because the NGS passing score leverages this solution, we will have the ability to evaluate quarterback play at the season, game, and situational level, while still maintaining a consistent distribution shape of scores. Distribution of NGS passing scores by game and season. A passing stat that correlates with wins. So how does NGS passing score correlate with winning football games? We took a look at 202 individual seasons from 88 different quarterbacks over the last 4 years, grouped each season into buckets of 5, 95 plus, 90 to 95, 85 to 90, etc. Paired the win-loss record and percentage of playoff bursts across each bucket. So 95 plus has a 66% correlation to winning in the regular season, 80% in the playoffs. 90 to 94 passing score has a 64 correlation during the regular season and 63% in the playoffs. 80 to 85 has a 56% during the season and 40% in the playoffs. 80 to 84, 45 during the season, 23 in the playoffs, and so on and so forth. The relationship between a player's single season NGS passing score and winning percentage is quite strong. A score around 85 serves as an indicator of winning percentage near a 500 mark. A score above 85 and your team is more than likely winning with or rather than in spite of their quarterback. Score of 90 plus, those are the players you win because of. We group single season scores into 5 buckets at the single season level and with clear thresholds for quality of play. The distribution of passing scores to 80 as a rough Mendoza line for starting level quarterback performance. Quarterbacks falling below that line, are often young quarterbacks, often young players acclimating to the league, or replacement level talent that teams will look to upgrade from the following season. Quarterbacks falling between a score of 80 and 90 are a mix of guys you can win in spite of and win with. Finally, passing scores above 90 can be roughly considered elite, the players you win because of. For the last 4 seasons, there have been 2 quarterbacks finish a season with a score of 95 plus. Only 2, Deshaun Watson in 2020 and Derek Carr in 2019, played for teams that failed to make the playoffs during the season in which they reached that mark. The trade-off between correlation and stability. So how does our passing score compare to validity and reliability of the PFF passing grade and ESPN's QBR? Across identical samples, we investigated the correlation between each metric and measures of winning football games represented by win percentage, playoff percentage, and whether the team had a winning season. In addition to correlation tests, we also set out to evaluate the year-over-year stability of each metric. That is, for a specific player, how similar was the player's metric from one season to the next. Correlation of passing metrics and wins. From 2018 to 2021 single seasons, Next-Gen Stats had a 0.61 correlation to win percentage. PFF grade had 0.56 to win percentage. QBR had a 0.54 correlation to win percentage. In the playoffs, Next-Gen Stats had a 0.52. PFF grade had a 0.49. QBR had a 0.46. Winning season had a Next-Gen Stats had a 0.44. PFF grade had a 0.43. QBR had a 0.40. And year-over-year stability, Next-Gen Stats had a 0.42. PFF grade had a 0.52. And QBR had a 0.14. NGS passing score had a stronger correlation to win percentage, making the playoffs and finishing with a winning season that both PFF passing grade and QBR metric. While the PFF passing grade tops the chart in year-over-year stability, there is certainly a trade-off when it comes to both correlation and stability. A higher number is not always better. A metric can be highly correlated to winning games, but not representative of the individual's quarterback skill level. Conversely, a metric high in stability might not correlate with meaningful outcome of the value. Nevertheless, the decisions made during the modeling and aggregation process were geared toward the maximization of both objectives. More scores to come. This is just the beginning. We will continue to iterate and apply our scoring methodology to other advanced stats and position groups. The NGS passing score is a smaller component of an even bigger score, quarterback score, but that requires components representing rushing performance, the ability to avoid pressure and sacks, and even the elusive analysis of determining the optimal target at every time stat.